All right, welcome. Let's get you ready to absolutely master binomial option pricing for your professional exams. We're going to go deep, covering everything you need from the core theory to those tricky little details that make all the difference between just passing and getting a perfect score. So here's our game plan for today. We're going to build this up step by step. We'll start with the asset model itself, then get into the core logic of no arbitrage, see how that works in a risk-neutral world, derive the super important put-call parity relationship, and then we'll wrap it all up with a rapid review to make sure it sticks. Okay, let's dive right in. Look, before we can price anything, we have to agree on the rules of the game. We have to define the universe our assets and options actually live in. Think of this as the basic grammar for everything that follows. So let's start with the absolute basics. A derivative. What is it? The name kind of gives it away, right? Its value isn't its own. It's derived from something else. Now we're going to focus on stock options, but remember, that underlying could be anything. Interest rates, oil, you name it. The logic we built here, it's universal. And this, right here, is our playground. The binomial tree. It's a simplified map of reality, but it's incredibly powerful for pricing. The key assumption is that time moves in discrete steps, and at each step, the price can only do one of two things: move up by some factor u or move down by some factor d. That's it. Simple, but powerful. Now, here's a technical term that you absolutely have to know: filtration. It sounds complicated, but it's not. All it really means is what we know and when we know it. So if you're at any given spot on the tree, the filtration is just the unique path, the history of ups and downs that got you there. It's all the information you have at that exact moment. Okay, let's move on to the absolute cornerstone of all modern finance. This is the engine. This is the logical principle that lets us price derivatives with total mathematical certainty. And this is the amazing part, without ever needing to know what's actually going to happen in the real world. This really lays out the central problem, doesn't it? If you wanted to value something based on its future payoff, you'd normally need two things we just don't have. One, the real probabilities of the stock going up or down, and two, the right discount rate to account for the risk. The absolute genius of this model is that it finds a way to completely sidestep both of those impossible questions. Let's make this concrete. Take a look at this call option with a strike price of 90. If the stock ends up at 120, great, the option pays out $30. If it ends up at 80, well, the option is worthless. So the question is, what's it worth today, right now at the start? And here is the incredibly elegant solution. We build something. We construct what's called a replicating portfolio. The whole idea is to create a mix of the underlying stock and some risk-free borrowing or lending that perfectly matches the option's payoffs. We carefully choose exactly how many shares to hold against the option we sold, and poof, we create a position where the final value is the same no matter what happens. So here's the punchline, the crucial point. Once that portfolio's future value is guaranteed, it is, by definition, riskless. And in a world with no free money lying around, no arbitrage, any riskless asset must earn the risk-free rate. It just has to. If it earned more, you could borrow at the risk-free rate and lock in a free lunch. If it earned less, you do the opposite. You see what just happened there? That whole process, that insistence on creating a riskless portfolio, it forces us into a very specific, very powerful framework. We've implicitly stepped into what we call a risk-neutral world. Now let's really focus on this comparison, because it's huge. On the left, you've got the real world, where people are afraid of risk and demand extra return for it. But on the right, in our risk-neutral world, we've engineered the risk away, so we don't need to guess what the real probabilities are. Instead, we mathematically derive the one and only set of probabilities that is consistent with no arbitrage. And this is what it all boils down to, the general valuation formula. It just says the option's value today is the discounted expected value of what it could be worth in the future. But look closely, we're using P, that special risk-neutral probability we just derived, and we're discounting using R, the risk-free rate. To price any option, you just start at the end of the tree and use this formula over and over, working your way back to the beginning. We call that backward induction. Okay, pay very close attention here. This is a classic exam trap, and I see people fall for it all the time. While the probabilities are different between the real and risk-neutral worlds, the volatility of the stock is the same, and since the size of the up and down moves, U and D, are just a function of that volatility, they are identical in both worlds. Get it? the size of the jumps doesn't change, only the probability we assign to them. All right, now we get to build on these principles to derive a fundamental, unbreakable law that connects calls and puts. And I mean it when I say law. This isn't just a handy formula. It's a statement about the deep structure of markets where there's no free lunch. So, the same replication logic we just painstakingly went through for a call option, we can do the exact same thing for a European put option. As long as it's on the same stock with the same strike price and the same expiration date, the mechanics are 100% identical. So what happens when you build those two replicating portfolios, one for the call and one for the put, and you combine them? Well, a little bit of algebraic magic happens, and out pops this fundamental identity. The price of a call plus some cash equal to the present value of the strike price must equal the price of the stock plus the price of a put. It has to hold, always. And this is the most important thing I can tell you about put-call parity. Please burn this into your brain. It is not just a pricing trick. It's a balance sheet identity. It's basically the law of one price. It says that two portfolios that have the exact same payoffs in the future must have the exact same price today. If they don't, there is a riskless profit just sitting there for the taking. Okay, let's pivot. Time for pure exam prep. We're going to use some memory aids to lock these concepts in, and then we're going to blast through the most critical must-know facts that you are almost certain to see on the test. Use these little tricks to lock these rules in your head so you can recall them instantly under pressure. For put-call parity, just think call plus cash equals stock plus put. To remember if a call is in the money, remember SLIM. Strike lower, I'm in the money. And for the whole valuation process, it's EWB. Start at the end and work backwards. All right, ready? Let's do this. A rapid-fire review of the 10 most critical facts. 1. A replicating portfolio's payoff has to match the option's payoff in every possible future state. 2. The whole model is built on one assumption, no arbitrage. 3. If a portfolio is riskless, you always discount its payoff at the risk-free rate R. 4. Risk-neutral probabilities are not forecasts, they are implied by the math. 5. Pricing is always done with backward induction, starting from maturity. 6. Your time step, dt, is the total time t divided by the number of steps n. Don't mess that up. 7. U and d, the size of the price jumps, are based on volatility and are the same in both the real and risk-neutral worlds. 8. The delta is just the number of shares you need for that replicating portfolio. 9. Put-call parity, C plus key to the minus RT equals S plus P. You have to know it cold. And 10. Put-call parity is not just a formula, it is a fundamental balance sheet identity. It's a law. And that's our deep dive. So I'll leave you with this final thought. If this is a true balance sheet identity, and you found it was out of balance by just a single penny, what specific risk-free trades would you make right now to grab that penny? When you can answer that in your sleep, you've truly mastered this.